Good morning. My name is Clumsy Lynx, and I am the blacksmith of the Northern Blacksmith Consortium at Frontiers Camp. And I'm going to be spending this week talking with you about clouds, which is one of my passions. I love weather and clouds and learning about them and observing them, taking pictures, and I wanted to share that with you because clouds are always there to look at, and if you know a little about them, then they get to be really interesting, and you can even use them if you know what you're doing to predict the weather. So, what are clouds? Clouds are water droplets or water crystals that are in the atmosphere, and they form under certain conditions of temperature, pressure, and relative humidity, the amount of moisture in the air. Most of the time, we have quite a bit of humidity in the air in the form of water vapor, but water vapor is invisible. You can't see it. So it's not until you have a water droplet or water crystal that you actually have a cloud. Clouds are formed with moisture, like I was just saying, and that is caused or helped by the water cycle. And you all learned about the water cycle in school at some point, but I'm going to go back over it. Why not? So the water cycle is that somehow, either through the sun or by heat from the earth or some other process, water evaporates from liquid water in a lake, pond, stream, river, or ocean and becomes gas and then floats up because warm air rises. As it floats up, at some point, it hits a pressure and temperature and amount of moisture, which then can then coalesce around a piece of dust, and that will become a water droplet or a water crystal. Those are then kernels, and you can gather more and more, and these droplets can get bigger and bigger. And at a certain point, the droplets are so big that they're so heavy that they fall back to the earth, and we call that rain, and that gets collected again into streams and rivers and oceans and lakes and things, and the cycle continues. So clouds only happen between the ground and the top of the troposphere. The troposphere is the part of the atmosphere in which all of our weather happens. The height of the troposphere is different depending on where you are in the world. The troposphere is about 10 kilometers, 6 miles thick here in Vermont. But down at the equator, it's about 18 kilometers or about 10 miles thick. And up at the North Pole, it's much thinner, where it is something on the order of 7 kilometers or 4.5 miles high. So depending on where you're at, the definition of a high, middle, and low cloud, which is we'll get into in a moment, changes. But in general, for us in North America, we can look at it and say, okay, that's pretty much between the ground and 6 miles or 10 kilometers. That's where our clouds happen. Anything above that, there's not enough moisture there. And actually, above the troposphere, from the ground to the troposphere, the temperature goes down as you get higher and higher, but you hit something called the tropopause just before you get to the stratosphere, and in the stratosphere, oddly enough, the temperature increases the higher you get. So all of what we're talking about in clouds happens between 0 and 6 miles or 10 kilometers. We're going to be talking about types of clouds, and we're going to learn how to identify clouds. And once we learn how to identify them, we can even use them with our understanding of warm and cold fronts to predict the weather. So what are the 10 types of clouds? Now, there are more than 10 types of clouds. There are subclasses of clouds and unusual clouds, which we're not going to go into deeply, but we're going to skim across as an idea. But the 10 main types of clouds are categorized based on two things. They're based on their shape, and they're based on the height that those clouds form at in the troposphere, the atmosphere. So we'll start off by learning the cloud shapes. There are 3 types of cloud shapes. The first type is cirrus. Cirrus is a wispy feather-like cloud, sometimes called horsetails, sometimes called feathers. It's a streaky cloud, and those clouds are all made up of ice crystals. Next we have cumulus. Cumulus are the billowy white clouds that we're used to seeing in the sky, those happy small clouds, but all the way up to storm clouds are made up of this type of cloud. And cumulus clouds are pillowy. That's the Latin word cumulus is pillow, and they look like cauliflower, and those are all made up of water droplets. And then we have stratus clouds, and stratus clouds can either be made up of water droplets or water crystals, but the stratus cloud is a sheet, which is what it means in Latin, or street, stratus, street. And these are long sheets that cover a large part of the sky. The second thing, we have shape. The second thing that we use to identify clouds is the height at which they form at. So we have high clouds, which form very high up, which are have the prefix cirro. We have cirrus itself, but then we have cirrostratus and cirrocumulus. Then we have the alto clouds, the middle high clouds that use the alto as the prefix, and that is alto stratus and alto cumulus. And then we have the low clouds, and those don't have a prefix. So those are stratus, nimbostratus, stratocumulus, and cumulus clouds, and those all happen in the low area. Now, like I said before, there are some clouds that break these rules, and one of them is the cumulonimbus. The cumulonimbus starts as a small cloud, but then gets bigger and bigger and reaches up, and most of that reaching up looks very cauliflower-like until the very top where it gets very streaky and forms that anvil, and it's at the top where it gets streaky where those ice crystals are formed out of those water droplets, and that creates a huge temperature differential within the cloud cell, and that creates convective currents, and there's a lot of energy in that going over all those different layers from almost on the ground to all the way at the top of the troposphere, and that is a storm cloud. Okay, so just to go back over it, we have high, middle, and low clouds, and then we've got clouds that are more than one or are on the boundary of 2 different areas. So starting with the high clouds, the cirrus, we have the streaky clouds, those feather clouds. Then we have something called cirrostratus, and cirrostratus is a very thin sheet of ice crystals very high up in the atmosphere, and it's a stratus, it's a sheet cloud, but it's so thin that you can't see it except that it shows as a halo around the sun. So if you look up at the sun and you see a halo around it, that halo is being created by those ice crystals very high up in the atmosphere, and it's a thin sheet. And we also have cirrocumulus, which are little puffy clouds. They are ice crystals that high up, but they form these little groups, these puffy groups, and that's the cirrocumulus. Down the altos, the middle high clouds, we have altocumulus, which is the same type of cloud that you saw in the cirrocumulus, but they're lower and they're more puffy. Some people like to say that it looked like sheep wool. And then you have the altostratus, which is a higher cloud than a low cloud and lower than a high cloud, but is that long, thin sheet, sometimes darker on the underside because the sun can't get through it. And then we have our low clouds, and those clouds are your stratus, which also includes fog. A cloud on the ground, which is a stratus cloud, a street-like, sheet-like cloud, that is, if it's on the ground, it's called fog. So we have clouds on the ground. Then you have cumulus. Cumulus are the funny little clouds. They can be small and individual, or they can group together and get bigger. The small individual ones are actually called cumulus humulus, which translates from Latin into funny little cloud, a funny cloud. So the cumulus can then grow to be a cumulus mediocris, or a mediocre cloud, or cumulus cloud, and that can then become a cumulus congestus, where it starts stacking on top of itself. It's congested, and that can then turn into a cumulonimbus, where it reaches all the way up and you get that anvil at the top. Other clouds, which are not based on the height necessarily, that we need to know about are our stratocumulus. Is a very common cloud. The cloud is dark on the bottom, it's lighter on top, and you can usually see patches of blue sky behind it. This cloud can have rain, but never has lightning, and often doesn't have rain. Then we have nimbus stratus. Nimbus stratus is a low cloud, but it does breach into the middle high clouds, and that is what we get most of our rain and snow from. That is not storm rain. It's a steady, long, steady type of precipitation, and that precipitation, either whether snow or rain or sleet or whatever, never has lightning involved with it. So both the stratocumulus and the nimbostratus can give rain, and the nimbostratus often does, but neither of those have the energy to create lightning. And in the graphic I'm about to show you again, you can see how that cumulonimbus, that storm cloud, goes through all of those layers, and that's what gives it the energy to create very strong winds, high amounts of storm-type precipitation, and lightning. So here's that graphic again. Now that we've had a primer and we know that it's the shape coupled with the location or the height of the cloud that we use for identifying them, we can take a look at this now and look at our high clouds. We've got our cirrus, our wispy clouds. Then we have the halo around the sun. That's that cirrostratus. And then we have a cirrocumulus that they're calling mackerel sky. Going down a level, we have two clouds at the alto level, and that is an altocumulus, which is again the puffy clouds, and an altostratus, which sometimes is that milky sky. Then down at the low, we have our stratus, which if it's on the ground is fog. If it's not on the ground, it's just a stratus. We have our stratocumulus, which was that cloud that had dark bottoms and light tops, and you can sometimes see the blue sky through it. That can sometimes have rain. Nimbostratus, which is a sheet cloud that is always gray, kind of undifferentiated, and can have very long periods of steady rain or snow or sleet, but not lightning. And then we have our cumulus clouds, and our cumulus clouds are our happy little cumulus happy little clouds. And then over on the right here we have the cumulonimbus, and you can see that the cumulonimbus has a lot of cumulus on the bottom, and then as it goes up gets that anvil top, and it's that fact that it crosses all of these temperature boundaries. It's got a very cold top and a very warm bottom. It creates a rising and a falling, a convective current, and that creates strong winds and lots of strong rain, and also the propensity for lightning. So the only one of the clouds in this entire thing that can give you lightning out of the standard clouds, there are some funny odd clouds which we won't be going into in depth that can also have lightning, but the cumulonimbus is the storm cloud, is the thunder cloud. So here we go. I was saying there are main types of clouds, but there are also lots of subtypes of clouds, and here are just a taste of three. There are some awesome weird clouds that happen under very particular conditions, but here are some very fun ones. One of them, which you may have seen, is called lenticularis, and lenticular is Latin for lens shaped, and these are clouds that often form on top of mountains, because mountains change the pressure. I said that we have three things we need to think about when we're thinking about why clouds form. You have your moisture content, there has to be moisture. You have your temperature, you have to be near the dew point, and you have your pressure. And you can get a point where the pressure, the temperature, and the amount of moisture is exactly right, And the mountain, you can have some clouds or some air that has quite a bit of moisture in it, is not quite warm enough or cold enough to hit the dew point, and then you hit a mountain, which increases the pressure. The air is forced up, and that increases the pressure, and suddenly you have the perfect conditions for water to go from a gaseous form into a liquid form, of course forming on little dust particles, and that's a lenticularis. It often happens on top of mountains. It does not at all have to happen on top of a mountain. When it's on top of a mountain, it's often called a cap cloud as well. Then we've got virga. Virga is actually a cloud that is raining, but the rain evaporates before it hits the ground. So you're seeing the cloud, you're seeing the trail of rain come out of it, but it dissipates before it hits the cloud. So it looks like these kind of jellyfish clouds, and they're beautiful clouds. And then the last one, this is a fantastic cloud. I've never seen Mama in real life because it's really uncommon in our area. But Mama, as you can see, is called Mama because it looks like the udder of a cow or mammaries, and that's where the word comes from. And it is so full of energy, and it's really dangerous. This cloud can have lightning, it can have hail, it can have high winds. So if you looked up at the sky and you saw these weird, lobes of cloud coming down, that's time to get some cover, because that is a very unstable environment with lots of energy, and that energy has got to dissipate to somewhere, and you don't want to be there when it does. Okay, so that's a primer on the clouds. We now know that we have shape and we have height, and we can look at those clouds and identify them, which we'll be doing this week. And then how do we use it to predict the weather? Well, here's a standard weather map showing L for lows and H for highs. The lows are called lows because the barometric pressure, the pressure that the atmosphere exerts on the ground, changes for the different types of weather. And if you can actually see, if we could visualize this, it's actually a dip in the air. The air is got a lower, it's literally lower. Just like if you think about a tornado or a hurricane, these are spinning amounts of air always above the equator. Low pressures are always counterclockwise and high pressures are always clockwise. But that's kind of like, watching water go down a drain. You've got this dip, and that's exactly what's happening. And that can be read using a barometer, looking at the barometric pressure. The highs and the lows act like gears in a gearbox, with the highs going clockwise and the lows going counterclockwise, and they kind of fit together like gears. If you want to know more about it, why that happens, it's part of the Coriolis effect, and I'd be happy to go further into that. So when we're looking at that map, we're not just seeing L's for lows and H's for highs, we're also seeing these fronts, and there are three kinds of fronts. One is a warm front, and that is a red front with these little half circles on top. One is a cold front, which is a blue front with little blue triangles. And one is an occlusion, which is a purple, which has a mixture of the two. The occlusion is something that you always treat like a cold front as far as what you're expecting for weather, because basically you'll have a warm front moving along and the cold front will catch up with it. And when it catches up with it, you get this occlusion, and it has the characteristics of a cold front as far as predictive power and whether or not you're going to possibly get storms and lightning. So looking at this, we can say, okay, there are a bunch of lows, there's a couple of warm fronts, a couple of cold fronts. There's some other stuff on there that I won't get into right now just because I want to make sure that we understand the concepts we're talking about. But meteorology and weather in general is something I'm passionate about, and I'm an amateur meteorologist. So if you want to get into it deeper, I can. So how can we use these to predict the weather? Well, let's look at what happens when we're dealing with a cold front. So with a cold front, as this graphic shows, as this picture shows, you've got cold air coming from the right, and it's hitting the warm air in front of it. And since warm air is lighter and cold air is denser, it kind of forms a wedge under that warm air. And you can see what's happening. The pressure is changing and the temperatures are changing. So at the very leading edge of a cold front, you're going to start by seeing the cirrus clouds, those wispy clouds. And whenever you see cirrus, whether it's going to end up being a cold front or a warm front, that's indicative or shows that there should be some kind of weather, some kind of precipitation within 24 to 72 hours. So a day to 3 days. That's how good the prediction can get. So that's pretty wide, but it depends on a lot of factors: how fast the wind is moving, how long that front is. These are all things that would determine how quickly that front and those storms would actually be arriving. So when you're seeing the cirrus, the front has arrived, but not at our level. It's arrived way up in the atmosphere, and you see those wispy clouds. After that, you should see altostratus, that sheet of clouds very high up, but middle high clouds, and the altostratus would then go into a cumulonimbus, and that is that storm cloud. Now, this diagram shows some nimbus stratus in front of the cumulonimbus, and that's much more common in an occlusion front. So if you see your cirrus and you see your altostratus, and then you run into some nimbus stratus, that streak cloud, that gray cloud that has the steady rain, it doesn't mean there's not going to be a cumulonimbus behind it. A storm cloud could be hiding behind it. But it does mean as long as we're looking at that nimbus stratus, there's no danger of lightning until that cumulonimbus shows up at the very end. And that cumulonimbus is a dangerous cloud. You can have hail, you can have very heavy rains, you can have lightning and high winds. And the winds are going to be weird because the cumulonimbus creates its own winds because of those convective cells I was telling you about. So the predictive power of that is about 72 hours. A warm front is very similar. It's cirrus, and then altostratus, and then nimbus stratus. A warm front is not going to bring you a cumulonimbus. It's going to, most of the time, these are all most of the time, because all of this is generalization, and what's really happening on the ground is what you go with, not with what the textbook says, because every one of these things can change based on 1,000 or 1,000,000 different parameters that we have no way of noticing. So with a warm front, cirrus first, altostratus, and then nimbus stratus. And the nimbus stratus, once again, is not going to have lightning, but could have good steady rain for hours, if not days. Okay. Clouds happen in slow motion. When you look at a cloud, you're getting a literal snapshot of what's going to happen. If you can do slow motion photography, which I've done some slow motion photography, and I'll show you that during our live session on Wednesday, you really have to look at clouds in bits with time in between them to see them change. Now you can stand there and watch a cloud and you'll see it change, but you're not going to see often a change from cirrus to stratocumulus or altostratus to nimbus stratus in an afternoon. It does happen, but it's uncommon. You're usually going to have 10 or 15 hours between bits of that. So if you are going to be observing clouds, you want to look at it and then give yourself a couple of hours and look at it again, and then look at it, give yourself a couple of hours and look at it again. And that's the best way. And that's what I'm recommending for keeping your journal this week, that you do it in that way. So we're going to take a look at the sky out your window 3 times a day, approximately morning, midday, and evening before sunset. And we'll do that for a couple of days, and we'll talk about it, and then you guys can send in your journals at the end of the week and I can go over them, and we can take a look at that. I also recommend, if you have the ability to take a picture at the same time, and we can put those together and look at whether or not we agree on your determination of the cloud, and maybe even make a prediction of the weather. So what are we going to be collecting as far as data is concerned? We're going to be doing location. We're going to be doing temperature. If you can get barometric pressure, get the barometric pressure, because it's fun to track that as well. And what cloud is passing overhead. It is possible that there are more than one layer of clouds moving in different directions. So if that happens, try to identify all 3 clouds or 2 clouds and look at the direction they're coming in. Remember, if you don't know what the cloud is, do some research. And the last page here is going to be a link to the National Oceanographic and Atmospheric Administration's page that gives you the 10 basic cloud types. And that's it. If you, after this presentation, download the cloud spotting journal, you can get started today. And if you keep regular journal entries on your clouds with pictures, if you can, then we can see if you've been able to pick up the different types of clouds and maybe even predict what's going to be happening with the weather in the next 3 days. So that's it for me. Clumsy Lynx here at the Frontiers Camp virtual weather station, and I'll look forward to seeing you guys on Wednesday.